Okay, so this second video here, we're going to be talking about two different types of compound intervals. Okay, sorry about that. I got a little distracted. Somebody brought me in a little pumpkin bar treat thing. Okay. Anyway, so we're talking about compound intervals. So there are two types of compound intervals. There are bounded intervals, and there are unbounded intervals. Okay, now, your bounded intervals are going to involve and statements. And what I mean by that is these compound intervals, what they have is they have two x less thans or x greater thans. Okay? So this is going to be a case, the bounded interval is a case where you're going to be saying that x is greater than -2 and at the same time x is also less than -5. Okay? So for a bounded interval, you are going to be saying that the interval is bounded between two numbers. It's bounded between two values or two numbers here. Okay? So for my example here, I have -2 less than x less than or equal to 5. That is a bounded interval. Now, what two numbers is this interval bounded between? Well, this interval is bounded between -2 and 5. Okay? So if you guys see something like this is kind of how I say it in my head. When I see something like this, I'm like, okay, the x is between -2 and 5, so I need to shade between -2 and 5. Okay? Now that's kind of what I think in my head to remind myself of it. But you guys can also look at this and see x is less than or equal to 5. So that means x is less than or equal to 5. Okay? And then the other one, this one here, -2 less than x. Remember I said last time that we don't really write things that way? So I could flip the order of these and make this an x and then move the -2 to this side. So if I flip those, we have to flip our middle sign here also. So that becomes an x greater than -2. So how do we graph x greater than -2? Well, we graph it that way. So you guys can see with our blue and our red, we need something that is greater than -2 while at the same time is less than 5. Okay? And that's how we end up with this bounded interval where we have shaded everything in between. We've shaded everything in between 5 and -2. Okay? Now, along with this, we do still have to pay attention to our sign. So notice at -2, I have an open circle at -2. Why is that? Well, because that's just a less than sign. I have a closed circle at 5. Why do I have a closed circle at 5? Well, because that is less than or equal to. Okay, so we're still going to pay attention to our open circles and our closed circles. But the biggest thing that I want you guys to take away from this thing right here, is it's bounded. Okay, it's bounded between -2 and 5. The x is in the middle. X is in the middle. Okay, so that means we shade in the middle. Okay, now. Anyway, thanks for the interruption, Dad. Now, the other flip side of this, that would be the unbounded intervals. Your unbounded intervals are going to be talking about your or statements. They're going to be talking about your or statements. So for an unbounded interval, it means that a number is going to be something or it could be something else. So for example, we could have an x value that is less than -2 or greater than or equal to 5. So for this one here, it's not possible to have a value that fits into both of these cases, right? You could have a number that is less than -2, or you could have a number that's greater than 5, but they couldn't be the same number. There's no numbers that would work out for both of them. Okay? So an or statement or an unbounded interval is when something is not bounded. So that means that it's just going off in either direction to infinity. Okay? What's at the smallest number possible? Well, we don't know what that smallest number possible is because it's infinity. It goes on forever. What's the largest number possible? We don't know what that is. It goes off to infinity. Okay? So your bounded intervals are bounded between two numbers. Okay? Your unbounded intervals are both going to be shooting off into infinity. Okay? So bounded intervals will look like it's bounded between two numbers. Your unbounded intervals are shot off into infinity in either direction. Okay? Graphing unbounded intervals, I think, is a lot easier. I'm going to look at this first one here. X is less than -2. So less than means an open circle. And I'm going to shade to the left because that's where I go for less than -2. And then I'm going to do or. My other option I'm looking at is x is greater than or equal to 5. So greater than or equal to would be a closed circle. And it's greater than, so I need to shade off to the right. And that's how I'm going to shade unbounded intervals. Okay? All right, next slide then. We're going to practice this. Okay? It says, graph the following. I've got 2 less than x less than 6. I've got x less than or equal to 0 or x greater than or equal to -2. Pause the video, try and graph these. Okay, so graphing this first one here, the first thing I should do is I should be asking myself, okay, is this a bounded interval or is this an unbounded interval? Remember, my x is in the middle of 2 numbers. So if the x is in the middle, we need to shade in the middle. If the x is in the middle, we need to shade in the middle. So this is trapped between 2 numbers. It's bounded between 2 numbers. And those 2 numbers are 2 and 6. At my 2, I need to have an open circle. At my 6, I need to have an open circle. And again, I'm going to say it one more time. If the x is in the middle, we shade in the middle. So that's my bounded interval. X is in the middle, I shade in the middle. Okay? Over here for my OR statements, okay, OR statements are a lot easier to graph. I need to graph x less than or equal to 0. So I've got a closed circle at 0. I'm shading on to negative infinity. Okay? And then I've got x greater than or equal to -2. I'm sorry I had to pause the video there again because that is a very bad example to do. Okay, so what I want you guys to do is I want you guys to pretend like this says x is greater than or equal to a +2. Let's make that x is greater than or equal to a +2 there. Okay, so that means I'm going to graph x is greater than or equal to 2. So I'm going to put the number 2 down here. Since it's greater than or equal to, that means I am including. So I'm going to put a closed circle there. And I'm going to shade off into infinity. Okay, so sorry I gave you a bad example, but for this OR statement, making that a +2 instead of a negative, I've got x less than or equal to 0. Got that there. I've got x is greater than or equal to 2, and I got that down there. Okay, so this is an example of our unbounded intervals. Okay, the only other 2 things we've got on these videos is we're going to go over solving an inequality that is a compound inequality. So I've got -1 less than 2x plus 3 less than or equal to 5. Okay, a lot of people will see this these and statements and be like, oh my goodness, what am I going to do with that? Okay, well, remember when we solved equations, I told you guys that you can put a dashed line, and it's whatever I did on this side of the dashed line, I have to do on this side as well. Well, we're going to do that same thing with these, except I'm going to have 2 dashed lines. So both places where there is an inequality, I'm going to draw a dashed line down. And my rule is, whatever I do here in the middle, I have to do on the outsides as well. So I'm still trying to get x by itself. So my first step is going to be to subtract 3 to get rid of that there. But if I subtract 3 there, I also have to subtract 3 on both sides. So whatever I do in the middle, I have to do on the outsides as well. So now I've got a -4 less than a 2x less than or equal to a 2. Okay, and then the last thing that I need to do to get x by itself, I have to divide by 2. Okay, and when I divide everything by 2, I get a -2 less than x less than or equal to 1. So -2 less than x less than or equal to 1. Now, if I wanted you guys to graph this, what type of interval is this? I hope you guys are saying that this is a bounded interval because it is bounded. X is bounded between -2 and 1. Okay, so if I was going to graph this, I'd put my -2 and I'd put my 1. Okay, at my -2, there's an open circle. And at my 1, there's a closed circle. And again, this is bounded. It's stuck between -2 and 1. And I know that because since my x is in the middle, I shade in the middle. Since the x is in the middle, I shade in the middle. Okay? One more. Okay, last one I have here is if I have an or statement, I've got 3x plus 1 less than 4, or 5x minus 1 is greater than 5. Okay, so the nice thing, if I have an or statement, what you're going to do is you're going to solve this one for x. Then you're going to solve this one for x. Okay, so for 3x plus 1 less than 4, I'm going to subtract 1 on both sides. Gives me a 3x less than 3. Then I'm going to divide both sides by 3. And that gives me an x less than 1. For this one over here, I'm going to add 1. When I add 1, I get 5x is greater than 6. Okay? Divide both by 5. And I get x is greater than 6 over 5 doesn't really reduce. So x is greater than 6/5. Now, when I write my answer for this, it's an or statement, so I need to write them together. So I'm going to write x less than 1 or x greater than 6/5. Okay? If I was going to graph this, or statements are our unbounded intervals. Or statements are unbounded, so that means they go this way. Those are our unbounded intervals. All right? So my two numbers I need a 1. 1 would have an open circle, and it's less than 1, so I'm shading to the left. And then I've got x greater than 6/5. Okay, I've got 6/5. That's also an open circle, and we're greater than 6/5. So we're shading to the right. Okay, so that's how you guys solve compound inequalities. It's also how you guys will graph those compound inequalities. Only other thing you guys have left now is you need to do those on your own problems.